Good morning, my name's Professor Will Swan, Director of Energy House Laboratories and Project Lead for Energy House 2. I'd like to welcome you to the launch of the construction phase of Energy House 2, a £16 million project part funded by the European Regional Development Fund. Energy House 2 is going to be one of the largest building performance research facilities in the country. And as such, I'm really excited to be here in front of you to launch this phase. In 2011, we launched the Salford Energy House. It was a unique facility at the time. The principle of the Energy House was to address the performance of retrofit. Previously, we'd measured things in the field, or we'd measured small elements of a building in laboratories. The idea of testing a whole building under controlled conditions was genuinely innovative. It allowed us to conduct repeatable experiments with high levels of data granularity, which meant we could compress the time it took for innovators to understand how their products worked and indeed if they worked. Energy House 2 takes that principle and expands it massively. The size of the chamber in Energy House 1 is 1/7 of the chamber space available in Energy House 2. So nationally, we have major challenges around decarbonisation, around changes to our energy system, and how we get the benefits of those two things through clean growth and innovation. At a citywide level, we contribute to the Green City Partnership and initiatives such as the Energy Innovation Agency and the Retrofit Accelerator. So over the next year, we'll be reporting to you about this exciting project that looks to complete in early 2022. Once again, thanks very much for joining us, and now I'd like to pass over to our Vice-Chancellor, Professor Helen Marshall, to welcome you to the University.
Hello, I'm delighted to welcome you all today to the launch of Energy House 2. The new facility, which is starting to take shape on site, is going to transform what we can do here at the University of Salford in leading research into energy efficiency initiatives and energy efficient products. Now, the team you're going to hear from today are at the forefront of driving the net zero agenda locally, regionally, nationally and importantly internationally. Day in, day out, we're working with industry to develop new products, new technologies that will revolutionise the way we use energy. The Smart Meters, the Smart Homes Lab, which was opened in 2019, is the UK's first smart meter research facility. Bringing together academics and leading industry partners, it's already making huge inroads into innovating energy use and the cost savings that are associated with that. The Thermal Measurement Laboratory is helping to meet the UK's carbon reduction targets by making sure that industry can test everything from walls and flooring to loft and roof insulation to meet environmental standards. Now, over the last 10 years, work that's taken place in Energy House 1 has led to groundbreaking work that has influenced major progress in the UK housing energy efficiency agenda. Energy House 2, our researchers in Energy House 2 are going to be able to replicate the environmental conditions across the globe. So the minus temperatures and the plus temperatures are massive. The environmental and climate condition variations are huge. That will give us international opportunities. Working with international industry partners, no matter whether they're from Lapland or China or Bali or anywhere in the world, it doesn't matter the climate, we can work with them. This will help solve major global challenges. That's because that's our aspiration at the University of Salford. Working with industry is what we do and the way we do everything. And that's why you've been invited to the event today. We want to partner with firms large and small, public sector, private sector, government, regionally, nationally and internationally to address these common objectives. Because climate change is an important factor in all of our lives, and particularly for the forthcoming generations. So Energy House 2 is set to become a world-leading facility at the cutting edge of international research and testing in this space. It's not an academic ivory tower. The facilities that are being built are designed to help businesses tackle real-world challenges and solve real-world problems, improve their products, boost competitiveness and make a real difference to our environment. So please take it all in for the next hour or so and join us on the next step of our journey. We cannot do it without you. Thank you so much for your contribution, and we look forward to working with you. Thank you very much. Stay safe.
Thanks, Helen. So here we are back where it all started in 2011 at the original Salford Energy House. It was a project led by Nigel Mellors, who sort of had a bit of a brainwave about how we do things differently and testing things at the whole house level. So at the moment, I think we may have some technical difficulties, but Andy Burnham is due to join us. I think one of the things I wanted to say before he does join us by phone, I think, is over the last 10 years, we've worked very, very closely with Greater Manchester and the City of Salford, because energy and housing is essentially, it's a place-based issue. You know, it's about fuel poverty. It's about improving our homes and building zero carbon new homes. So I'm just going to check and see if Andy can join us.
Good morning, everyone. I hope you can hear me. Sorry about the technical difficulties, but I wanted to be on the call this morning just to show my strong support for Energy House 2, but also Greater Manchester's full backing for this project, because it's very much central to the goal we've set of being a zero carbon city region by 2038. We're confident that that's the right goal to set, particularly coming out of the pandemic. What we need to do is to accelerate recovery, to make it a green recovery. And we believe there are thousands of jobs to be created in the retrofitting of our properties across Greater Manchester and in building the homes of the future, adopting modern methods of construction. We are working with Electricity Northwest and with Cadent on decarbonising the grid, the energy grid, by the date 2038. We believe it can be done. But of course, what we now need to do is to accelerate progress and bring the construction industry together with the property industry, together with innovative manufacturers and energy suppliers, to give people those zero carbon homes right across the city region. And the reason why this is so attractive to me is because if we can become a leader in smart homes into zero carbon homes, obviously we are training a generation of young people in skills that will last them for a lifetime, as other parts of the UK catch up with the lead that Greater Manchester has set. So this has got to be a top priority at this particular moment in time. As part of our ambitions for 2038, we have set a date of 2028 in the latest version of our Greater Manchester Spatial Framework as the date by which all new developments in Greater Manchester will need to be zero carbon. So alongside the drive to retrofit our properties, we also have to start working with universities and colleges to train a generation in those skills, those modern methods of construction. And I see Energy House 2 as a centre of excellence to drive all of this, a place where business and colleges can go to learn about the latest technologies and to put in place the support that will be needed to find out about how we innovate in this space and make Greater Manchester a true leader in smart homes, zero carbon homes. So I'm really pleased to be joining you this morning. I'm sorry it's not the way that I wanted to, but just wanted to show my full support for what is being done here. I would like Energy House 2 to be under the spotlight of the COP in Glasgow next year when the world comes to the UK to renew our commitments to climate change. I want Greater Manchester to be firmly in that international spotlight, showing what we're doing as a centre of excellence in the green economy. Energy House 2 is a big part of that, So we're really pleased to support this amazing investment in Greater Manchester. Congratulations to all of our colleagues at the University of Salford for bringing this project through. And I just want to reiterate again, it has our full support. Thanks, everyone.
Thanks, Andy. It just goes to show there, Greater Manchester, we can solve all problems, even technological ones. So yeah, thanks very much, Andy, and thanks for your time as well.
No problem.
Thanks, Andy. Cheers. I'm Dr. Richard Fitton. I work here at Salford Energy House, Energy House 1, as we've had to now call it. So it's down to me to introduce you to the technical side of what we're doing, and also to introduce you to the existing facility and the new facility as well. So this will be a short presentation. It's got a video that I'll talk over in a couple of minutes as well, and then we're going to carry straight on. So Energy House 1, we opened in 2011, which is a long time ago now. We've credited ourselves with about £1.5 million of research income, plus a lot of other commercial research on our other units that surround the Energy House as well. And we've always kind of prided ourselves in the whole ambition around retrofit. So retrofit was why we were started, and that's why Nigel Mellors kind of set up the unit as well. And that we think we've made a significant impact around that area. So we've generally worked around retrofit fabric and insulation, air tightness, smart controls is something that we've kind of leaned right into in the last 5 or 6 years. Then along came vehicle charging, things like vehicle to grid, which is a different thing. We've had to assemble parts around the facility to kind of cope with that. Building performance technologies and methodologies is something that we kind of really pride ourselves on. That wasn't what we started up to do, but the idea of coming up with new methods to measure the performance of buildings has been something that's really taken off, actually. And sitting in the middle, you know, we look at the commercial testing of energy savings devices. That's at the heart of what we do as well, aside from the academic research. And it takes up about, I'd say, about 2/3 of our time and income as well as commercial testing. So as you'll see from just a selection of logos on the bottom there, we've worked with some pretty big names, and we also work with some very small names, and we pride ourselves in doing both, really. So it was a world first. That meant it was quite testing at the beginning as well. And any world first is difficult, but I think we got there. So it's used by researchers and industry from all around the globe. We started off with our standard temperature range, -10 to +30. Then we added rain, then along came wind. Solar radiation was our latest addition, and snow is something that we've always kind of done, but maybe not done a great deal of. That might be something that changes in the new facility. And sat right in the middle of that chamber is a fully functioning UK terrace, which is very representative of kind of 23–24% of the UK housing stock. So we did that a long time ago, you know, coming up for 10 years ago, and you know, Will and I sat in an office and we decided that we wouldn't kind of carry on developing in little bits with the Energy House, although it will never stop. And it's with us. It's a fixed asset. We're not going to it's not going anywhere. But we needed to make it a leap. So you know, the step process is nice, but we needed to make a big jump. We needed more space, without a shadow of a doubt. More flexibility. Again, we're tested in that building because we can't do a great deal with it in terms of where it's sat. Accessibility. Every brick that you see in that background image was brought down a corridor. And you know, through a small set of doors, and we constructed it in the chamber. And we needed more environmental variation to cover a larger proportion of global buildings, and particularly global dwellings. So that's kind of what we set ourselves the task to do. And we set ourselves that task 5 years ago, more or less, not far off to the day. And the background you see there is my idea of a blank sheet of paper. So we started off with a blank sheet of paper, and this was this pen sketch that was done on my desk at one of our early morning meetings. Will and I was our idea, and it's all hopefully built on this. And the idea was we build a big thing and we put a number of different houses in it, and then we make it so big that we can build inside, and we have big doors so we can get big planting. So the idea was big, you can safely assume. That then went on to a initial design. So we came up with this idea of having 3 chambers, and we put different houses inside them. with the idea that the plant rooms would divide the 3 chambers. So that was in 2016 by the time we got there. So all these things take time. Then we had this concept, and the concept there was a really beautiful building surrounded by beautiful fenestration all around, and it was lit from the inside, and it was an amazing building. 3 chambers with a street scene running all the way through it. So basically you had a street running the length of the chamber. That kind of went through a process of value engineering, as these things always do, and we ended up with this type of building, which is simpler, sleeker, and a little bit smaller as well. And after a process of value engineering further, 2018 we finally got there. So 2018 saw the final design, if you like, the final more or less frozen solution. And this really is a building that we are constructing at the moment. Okay, so this is our basic building that we're working on now. And it's going to take you on a tour around the site. So we started off with this idea: we have to have a big building, we have to get big plant in there. We needed 2 large chambers, and we also needed somewhere where we can build inside. And to build inside, we need things like foundations. So we need big pits that sit inside. So the big pits that sit inside allow us to build houses actually inside, the same as we would build in the real world. So the ground, the soil, the conditions in the soil affect the performance of the building. We also needed to allow for plant cranes, things like that, to get inside and to build the houses, actually in the chamber environment. And for scale there, we've got 2 houses on the right. There's Energy House 2. So if we Energy House 1. So imagine if we dropped Energy House 1 inside, we could get 2 versions of the same building. So we can get 4 houses, 4 moderately sized detached houses within the chamber. We can also put cars next to them. So cars are a considerable part of a full energy system within a building now. And the idea of vehicle to grid is one that's accelerating really quickly. The climatic chambers were needed to be deeper and higher. So -20 to +40 gives us this whole idea of covering 95% of the global population. Not the land mass, the global population of where people currently reside. So that to us was really important. And this idea of getting different buildings from all around the globe and putting them in one place where we can run them through a series of climatic conditions. So you see it here snowing, and then you're going to see things like snow and wind and rain cropping up as well. So this idea of having a building that can put another dwelling through exactly the same climatic conditions of more or less anywhere on the globe is a fascinating prospect. So we can take a building from China and see if it works in China, and also if it works in Manchester, for instance, and any place in between the two. And we can do that extraordinarily quickly as well. So, we talk in field trial language of around a year to put a package of measures together. So then we have this whole idea of not being able to test just houses in there. So the automotive industry has approached us a number of times and asked us to test cars within there. Caravans has been mentioned, sleeper rigs on wagons and things like that. We can really test a lot of different things within there, and we can couple other things inside it, such as hospital wings. We've talked about with the NHS Trust locally. So there's a lot of different things that we can do. So I'm just going to bring my slides back on now. So where we're currently up to. So I can speak very safely where we're currently up to, because I was stood in the pit where that gentleman was stood there only yesterday, in soil sensors and temperature sensors into that mud. So we're at the point now where the foundations are poured, the chamber pits are excavated. So this is the exciting bit. We're down in the mud now and putting our own sensors in. These are the pits where the foundations of the actual buildings that we construct in the chambers will be constructed. It's scheduled to be complete in December 21, so that's practical completion. So that's the point when we will start putting our monitoring systems in there, and other homes will start to be built in there, and we open to the public in March 2022. So here's some ideas of kind of where we're at. So you see all the pile caps are all in, the chamber pits will be poured, I think, the beginning of next week. So we'll have 2 large concrete chamber pits cropping up. Then we'll start the steel work. So as you can see that it's all going on the site. For those who are like me, who are interested in these things, if you click to the Energy House 2 website, the link will be on at the back of these slides that we do today. There's a time-lapse camera on there, so you can get a fascinating kind of bird's eye view of every 10 minutes this gets updated, so you can see how the site is progressing. That camera will move around the site as we come to approach different parts of it. So we're also looking to partner with industry and academia globally and locally. So, you know, we are very interested in talking to people in the business of off-site construction, people who are looking at small commercials, hospital wings and things like this, which we've seen develop very quickly as the ongoing pandemic has kind of made us build these things quickly as well, and temporarily. Novel construction methods, I think, is always something that we're interested in. Energy systems and the idea of assembling buildings with PV, batteries, V2G, different energy vectors as well, such as hydrogen, are all something that we are aiming to develop, you know, significant testing abilities in that property as well. And the automotive industry and thermal performance is something that we are really interested in at the moment. So I personally believe, and I hope there's a lot of people who would agree, that this is a pivotal moment in the energy performance of buildings. This is where we can start to dig deep into what we're doing in terms of off-site, modern methods of construction, and different housings that occur all around the world. And this is not houses, it's emergency shelters and things like that, the really important stuff. So we've got research grade sensing systems providing really reliable results. We cover the main energy vectors, so gas, hydrogen, electric, PV and ground source will be covered in there. We're looking at systems, not just houses. So this is how a fabric performs with the car, the battery, the PV, the air source and occupants. So Energy House 2 is designed with a specific intent that people can live in all of those 4 houses. Energy House 1 fell down slightly in there, but you know, we have people in there for short periods of time. This building, people can live inside the houses that are built. Rapid validation of energy performance. You know, we're talking weeks and months, not years, to roll it through the entire climate of the country and the entire climate of the several countries, if we wish. And we get customer feedback in real world settings, so we can put people in a building looking at thermal comfort. We can say, what was the building like in the winter? What was it like in the summer? And we can run through that process in a couple of days. And then people can actually tell us what they feel before we start doing it. And if we find things wrong, which we inevitably will, because it's the construction industry and these type of things happen, we can make the improvements instantly and retest and find out what the actual difference was. So if you want to get involved, this is the email address. It will be on at the end of the slides as well. This is the website with the links to all the live stuff that's going to come on there. That will now become more live now we've launched the property and the construction process has started. So hopefully we'll hear from you people soon. So now it's over to Greg Jackson. So Greg Jackson's from Octopus Energy. Octopus Energy have supported the Smart Meters Lab as part of our research unit a lot. They've worked with the Energy House a lot, and they will provide the smart metering infrastructure and some of the data infrastructure as well behind the Energy House 2 test facility.
Well, isn't this cool or hot, depending on what you want to do with it? The magic of Energy House 2.0 is you can choose. And I think we're incredibly proud to be a small part of it. Look, the way energy is changing, I mean, everyone knows about the kind of increasing cost effectiveness of wind and solar energy, replacing gas and coal. But people are not thinking as much as perhaps they need to about the changing consumption of energy as well. And I think obviously we've got emerging technologies like electric vehicles are going to be the new normal, but also things like the decarbonisation of heat and indeed the way in which a renewable energy system is not a like-for-like replacement from the old world. You know, National Grid used to be able to wake up every day and you know, have a forecast for electricity demand, and then they could turn coal and gas power stations on and off to meet those needs. But now they're going to have to wake up every morning and look at the weather forecast. and work out, when it's going to be sunny and windy, how much electricity we're going to have, and then, use a variety of technologies and price signals and goodness knows what else to enable the consumption of that electricity to match the generation. And that's just one example of the way in which so many of the assumptions about how things work are changing. And it's all well and good talking about that and then modeling it on spreadsheets. But actually, the real world never follows those kind of simple approaches. And I think it's incredibly important to be able to experiment with the way in which changing ways of using energy are going to change, flow right through the system, and identify the ways in which, not only can we start to adopt new technologies and adopt technologies that are going to make the world greener, but then increasingly understand that, we can actually make lives better through the ways in which we improve the fabric of our homes, the ways in which we make the most of abundant green electrons when they're available, and then think about what we might do when they're in shorter supply. Now, Energy Lab 2.0 is incredibly exciting to me, not just because of the fact we can model the coldest of winters here in the UK, and the hottest of summers, but actually, look, Octopus Energy is typical of what's going to happen, which is energy is globalizing. We face the same problem everywhere. And for Octopus, we've got customers in Texas and Germany, in Australia, and here in the UK, and being able to model, we're an example, but for people to be able to model and experiment with all those different climates and work out how we can better meet the needs of tackling climate change whilst improving people's lives and driving down costs. There's going to be no place better to do that than here at Energy House 2.0, which, by the way, I think is not only one of the biggest research facilities here in the UK, but actually in the whole of Europe. So I hope everybody is as proud and excited as we are for the opportunities this is going to open up to really keep Britain at the forefront of the energy revolution.
Okay, and as Richard said, the smart and digital aspect of energy is something we've been leaning into over the last 5 years, and Octopus have been a big part in helping us achieve that, among other businesses that help us establish the Smart Meters Lab a few years ago. So the digital and smart system side is one aspect of it, but there's also another revolution going on, and that's around construction. So the transforming construction agenda is a big part of building low carbon and zero carbon homes. So our next speaker is a big part of one of the businesses that's leading in this direction. So I'd like to introduce the Technical and Innovation Director for Barratt Developments, Oliver Novakovic.
So I think in the medium term, what's shaping housing is very much carbon. Carbon's a big driver. We've got regulation changes. I think people and our customers are becoming more aware of carbon. It touches many aspects of their life. So I think for a house builder, we're seeing some step change in regulation. So what we're seeing is we've got the Future Home Standard, which is most likely going to set a 31% improvement in energy, and then in 2025 we've got a 75% improvement coming, but we've also got the requirement to use low carbon technology. So we're moving away from gas, so we'll see technologies such as air source heat pumps and photovoltaics coming in, and then all the way through, as a business, Barratt have set a target that we want to be zero carbon by 2030. So I think the agenda around carbon is clearly set, and that's really driving us towards looking at solutions. And what's great about the project is that it allows us to test things in a controlled environment. Opportunities, I think, I mean, obviously the key opportunity is we all recognise we've got to make a step change around the environment. Everyone knows that. It's clearly defined by many scientists that we can't continue on the trajectory that we're set. So I think the opportunity is that you know, as a company, Barratt can lead the way and show how it can be done, and we should do. You know, we're the largest house builder, we should be showing the way forward. I think the other opportunity specific to the Energy House is we get an opportunity to look at the technologies, as I've said, in a controlled manner. So we can actually apply them as close as you can to a live site, because it's actual houses in that environment. But what we don't have to do is then pass it on to customers, so we can push the limits, and that's important, so we understand what point and entry we need to make in these technologies. I think one of the innovations we need to not forget when we're looking at carbon is that we've also got to look that we're going to bring in things like electric cars, so how a battery is going to affect the way we use our home. So I think innovation, I think we've got a step change in house building that we haven't seen, you know, this type of change, this unprecedented change for a long time. So I think it will bring innovations all over the house. So I think what's great about Energy House 2.0 is they've set a great template with Energy House 1.0. You know, that's done some really great research, and I think it helped a lot the refurbishment market, but a lot of that knowledge has, you know, been able to help the new house build market. But you know, the issue they had is it was a single unit. It's a much smaller unit, if you like, to deliver the research. What Energy House 2.0 does is it's a much bigger capacity, and they've taken the learnings from their first project and moved into so you know, it looks like it's going to be able to do much more from a research point of view under a controlled environment, and test many more different innovations, which, as I've been saying, innovation is something that's going to come through and has to come through fast, and it's this type of project that allows that to happen, and so much better it's done with the university. You get that independence.
Thanks very much. Thanks very much, Ollie. That's a great endorsement of what we're trying to do here from a major house builder. What we're here for today is to talk about the launch of the construction phase of Energy House 2. And what's really exciting, it's a unique building, it's a challenging building, and the next speaker is from Bowmer and Kirkland, and Neil Brook is going to just tell us a little bit about the project and what it means to Bowmer and Kirkland to be delivering such a landmark research facility.
We've been involved in the scheme now for just over a year, taking that sort of concept that Richard showed us a few minutes ago, and sort of working through that in the design of the construction so that will work. You know, because ultimately we want to deliver a scheme that achieves all the research credentials that Richard and his team want to be using the building for. To do that, we've had to overcome some fairly significant challenges, because generally buildings don't perform in the way that, you know, this building is designed to do. You know, buildings, you know, at the extremes, you may have a cold room that's performing it's set to perform at a very steady, you know, -20, -30 degrees. This building we're designed to perform from -20 to +40, puts huge challenges on the systems and the components that we build the building from, such as the steelwork. And as you can imagine, those climatic conditions, you know, these products want to expand and contract, and of course the building still needs to work and deal with those conditions. So, you know, things like the huge doors that Richard showed to get everything in and out. We have to put heating elements into those doors to make them work at those really cold temperatures. So all of that's taken some time to work through, such that, you know, we got to the period where we started on site a couple of months ago, and, you know, we really excited to have been involved in that process to conclude that design and make all those things work. Just then, sort of following on from some of the previous speakers about that sort of sustainability, that carbon neutral agenda. You know, like all contractors, like Barratt had touched on as well, you know, we have to take ourselves on that journey, and we do that with many of our clients. You know, we have been working with the Department for Education over the last 12 months to develop the first carbon neutral school, and we're actually on site now constructing that in the south of England. We've been developing that for a period now of about 2 years, monitoring, looking at all those smart controls and monitoring the energy usage within the schools that we've been building, such that we can learn all of those lessons to develop this carbon neutral school. People may have seen in the press recently as well, we have now started on site a large office building at the Noma area of Manchester. And that's a big office building that the client has got very much the aspiration to get a net zero carbon building. And that is looking at the energy and use of that building, how that we can incorporate smart controls, how we can design the plant so that it uses, so that you're not utilising large plant all the time in the building. So when the building is just occupied by a number of smaller users, that we've got plant that addresses those requirements. So that is the agenda that the whole of the construction industry is going through. And it will take time. I'm sure the research that Energy House 2 will be able to provide will assist us to get to that end game. Thank you. I'll pass now on to Joe Flanagan, who's the ERDF project manager, who's going to talk a little bit about the funding. Joe.
Morning, everybody. Well, I'm really pleased to be speaking here this morning. As just said, I'm the project manager within the Energy House team, and one of my primary roles is managing the sort of business engagement activities that the project is going to have over the next few months. We've heard today from Octopus, and we've heard from Barratt Homes about how they're excited about this new research facility. And, you know, they're big companies with big research budgets, and, you know, I'm sure they're going to make full use of the Energy House 2 when it's up and running. But if you're a small company, you know, what does it mean to you? How can you get involved? Well, pretty fortunate. We work very hard, and we've got quite a bit of grant aid for this project, and the European Regional Development Fund is providing us with about £8 million, which is really valuable in supporting the actual construction, but it's also allowing us to run a very big engagement program with small and medium-sized companies around the Greater Manchester area. So over the next sort of 18 months or so, we're looking to work with about 150 companies, helping them innovate and develop new carbon and energy-saving products. So what does that mean in practice? What it means is that our academics will be available to provide one-to-one support, technical advice. Companies will also be able to access some of our testing and research facilities. We'll be running sort of workshops in key areas, sort of smart meters, retrofit technology and home energy systems. And the really great thing about this is that for the companies that are involved, it's completely free of charge. And you don't hear that very often. We're about 12 months away from completing the construction of the Energy House 2 facility. But in the interim, we can offer access to some of our existing facilities, such as the original Energy House, our smart meters laboratory, our thermal comfort suite, and our thermal performance lab. So, you know, all those facilities are available for companies to come and use and help us develop their products. I think the other important thing is that, you know, the advice and whatever that we give is totally independent. You know, we're an academic institution. We pride ourselves on being independent and authoritative. So if you do come to us with a perpetual motion machine, we'll tell you it's a perpetual motion machine. So our message is really, if you're an SME, small and medium-sized company that's less than 250 employees out there in Greater Manchester, and you think you've got an idea, you've got a prototype, or you've got a product that you think needs a bit of testing or a bit of technical input, come and talk to us and we'll see what we can do for you. We've actually been up and running doing this now for a few months. So what I'm going to lead into now is just 3 short videos from Carolis at Evergreen Energy, Keith from Firmasil, and Lisa from Furlong Innovations, who we've worked with pretty closely over the past few months. I'm going to let them tell you in their own words, you know, how they benefited from working with us. Thank you.
Hi, my name is Carles, and I'm the founder of Homely Energy, a smart heating company connecting heat pumps with time-of-use tariffs, such as Agile Octopus by Octopus Energy. Our thermostat is able to optimize heat pump behavior to make sure our customers' heat pumps are operated during the cheapest periods of the day, delivering cost savings to our customers and helping the environment by using those green electrons. At the initial stages of the startup, it was very difficult to be taken seriously, especially when you were talking to industry professionals claiming you can reduce customer bills by over 20% by just installing a smart thermostat and asking those customers to sign up to a time-of-use tariff. This is where Energy House team has been instrumental in helping us gain credibility. We have approached Energy House team with a proposal to conduct a semi-controlled test of our smart heating system with a real-world heat pump installation at their Smart Meters Lab. Together with Salford University's team, we were able to set up the system, conduct the test, and prove that houses can in fact reduce their heating bills by at least 20%. Having these results has made our interactions with investors and industry players much easier, as now we had some real-world data to support our estimated savings. Since the testing, we were able to secure investment, number of contracts, and have recently been acquired by Evergreen Energy, where we can further develop our product and work on whole house optimization, connecting solar panels, batteries, heat pumps, and electric vehicles. Thank you.
Hi, my name is Keith Rimmer. I'm the inventor and founder of Thermosil Limited. This is Thermosil, and we'd like to show you a short promotional video. Thank you. Thermosil is ideal for retrofit or new build properties where Thermosil sits inside the newly installed window board. Thermosil is a passive device which is sustainable. It requires no energy to operate, yet it saves the consumers energy and saves carbon, focused at the government's net zero target. Thermosil is manufactured from 100% waste. Facilities like Salford University's Energy House are so crucial to the inventors, which bring inspiration to everybody. Unless your invention is proved positive, you're totally wasting your time. But the advice and the team at Salford are absolutely perfect for pushing people along and motivating you to go to the next stage. Thermosil comes with a business strategy and business model unlike any other. My whole passion for Thermosil is to help the fuel poor and the homeless amongst our communities. If you go to thermosil.com, you'll read all about the strategy and the model, but I'd just like to tell you a little bit about it. Profits will go into a trust fund called the Thermosil Trust Fund. The trustees will be from all walks of life up and down the UK. Part of the profits will then go back into purchasing modular, sustainable, energy efficient homes for the homeless.
I remember being amazed at seeing the Energy House One for the first time. A house inside the university, like a house that you could actually live in inside a building. Fantastic. Mole Group, we're a small drilling and moulling company, but with an innovative arm. And the University of Salford, although an academic institution, delivered the most practical, hands-on support that we could have wished for. CombiSave is a device retrofitted to existing combi boilers to speed delivery of hot water and save thousands of gallons of water per year. This and the associated carbon saving fitted perfectly with the Energy House purpose. It was fitted on the boiler in the Energy House for testing and was the setting for our video to show how CombiSave worked. And we had somewhere to take stakeholders to show the device in action and where we could hold a meeting after the demo. If you've seen the plans for Energy House 2, it's going to be even more amazing. A huge investment to study the future of housing. We work with Teddington, our UK manufacturer, to develop CombiSafe 2, which is a refined model to be fitted on Energy House 2. And university testing is going to evidence the enhanced benefits, and we're looking forward to working with Teddington, our UK manufacturer, on a refresher video to increase sales. In line with our company's environmental values, we've developed EVCC, or Electric Vehicle Charge Channel, to enable home charging for terraced homes or those with no off-road parking. We knew about the plans for Energy House 2, so it was an obvious call to make for advice and support to progress our clean air project. The Energy House team were as hands-on as ever and agreed a location on campus to install a working EVCC in the pavement, where we could demonstrate to stakeholders how installation would look and how robust and simple curbside charging should be. Again, we were able to film how to plug in your car and home charge using EVCC, and to use this video on our website. For an SME, being involved in a project as trailblazing as Energy House 2 can't be understated.
Okay, and thanks very much to Lisa, Carolus and Keith for those warm words. I think this is really what we're about. We're about innovation. We're about the opportunities of clean growth. And to close the session as our last speaker, I'm really pleased to welcome the Clean Growth Minister, Kwasi Kwarteng.
I'm delighted to be here virtually to celebrate the launch of your new R&D Centre, Energy 2.0. I think it's a fantastic initiative. The transition to a low carbon economy constitutes one of the most significant challenges and opportunities for the UK and the world over the coming decades. Meeting our net zero target by 2050 will require virtually all heat in buildings to be decarbonised and heat in industry to be reduced to close to zero carbon emissions. The government is planning to publish a heat and building strategy shortly, which will set out the immediate actions that we want to take for reducing emissions from buildings. These actions include the deployment of energy efficiency measures and low carbon heating as part of an ambitious programme of work required to enable key strategic decisions on how we achieve the mass transition to low carbon heat and set us on a path to decarbonising all homes and buildings in Britain. In making these decisions, we will need a coordinated approach and to make the most of local expertise while considering the balance between national and regional decision making. The UK building stock is unique because there's so much variety in the buildings landscape across the UK. But it means, however, that we must maintain a flexibility in our approach, recognising that there will be no one-size-fits-all solution in terms of the technologies that can be used to decarbonise. In light of this challenge, I applaud the development of Salford University's new R&D facility, Energy House 2.0. It's a fantastic initiative which will enable different types of housing stock and buildings to be tested. We know that innovation, whether through the creation of new technologies and systems or the refinement of existing ones, can drive improved performance and reduce costs. By enabling the market to explore more quickly, more cheap manufacturing and delivery, cost to consumers can thereby be reduced and technologies can be made more affordable. It is my sincere and earnest hope that Energy House 2.0 will make a major contribution to the Greater Manchester local industrial strategy's ambition for the city region to be carbon neutral by 2038 by working with SMEs to innovate their products and services so that they can be cleaner and greener. As the government looks to build back better from the COVID-19 crisis, I look forward to seeing how Energy House 2.0 will contribute to the research and innovation ecosystem and support businesses regionally, nationally, and internationally, so that together we can deliver a huge change in energy efficiency in buildings and also create growth and jobs in the green economy. I would like to encourage industry, academia, the third sector and advisory groups to continue to share knowledge and collaborate, cooperate, and to share their expertise to allow for a virtuous circle of innovation and growth. We will continue to make sure that evidence is systematically reviewed and looked at very closely when developing policies to make sure that the changes that we make to our homes are indeed the right ones to pursue. Thank you very much.
And I'd like to thank the Minister for those words. So that's our construction phase launch event, and really it's just incumbent on me now to thank a few people. I think as Richard showed, you know, it's not just me and Richard sitting drawing some sketches. To get to where we've got to today has taken an awful lot of effort. First of all, I'd like to thank all of the speakers who've taken the time to join us today, particularly the Minister and Andy Burnham, the Mayor of Greater Manchester. And I'd also like to thank the 350 or more than 350 of you who attended today. I think it just demonstrates the interest that is in the project. If you want to send any questions to us and follow up, please use the Energy House 2 email and we'll be more than happy to speak to you after the event. So just to close out, I'd just like to thank a few people. Obviously, we need to thank our funders, the European Regional Development Fund and MHCLG, who administer that fund. Particularly like to thank the environment team at Greater Manchester Combined Authority and also the team at Salford City Council who worked with us to get the project delivered into this phase. I'd like to thank the construction team, not just Bowman Kirkland, but also Bond Bryan and AECOM, and our own estates team, so Jason, Jody and Chris. Nothing gets done without finance, so I'd like to thank the team of finance, Mike, Debbie, Pauline and David, because it's an important part of delivering the project. And I'd also like to thank our own back office, particularly Joe and Charlotte. In terms of the production of today, I'd really like to thank all the team, Tareem, Charlotte, Morris for helping organise it, and obviously Andre, Ben and Neil, who've helped deliver it. A bit of a technical feat today because there's lots of videos, lots of live broadcasts, lots of links. So I don't think you need to underestimate the achievement of overcoming technology to deliver what we've delivered to you today. So I'd just like to really close by saying, please get in touch. This is just the start. We'll be keeping you updated. And those of you interested in working with us now, particularly SMEs, but also businesses looking in future to work with Energy House 2 and research and testing, we'll have an email address at the end, but please feel free to just get in touch and start the conversation, because I think, as a lot of the speakers have said today, the time is right for this project. There are a lot of agendas all moving together at once, and we feel that this is going to be a jewel in the crown of the research and innovation infrastructure, not just in Greater Manchester, but in the UK and potentially in the wider international scene. Thank you very much.